Myself, Dr.P.Anbarasan from St.Joseph Institute of Technology. Today we are going to see how to find the equivalent resistance and as well as how to find the current through each resistance. Okay, so we will have the two problems we can solve today. Okay, we will start with this problem. How to find the total resistance. From that, how to find the current through each resistance. Okay, after that we can have the one equivalent resistance problem. Okay, so see the circuit. The resistance are connected both in series as well as parallel. So first of all, we have to know what is the equivalent resistance for series connected as well as parallel connected resistance. So if two resistance are in series, you know what is the total resistance? The total resistance are given by R1 plus R2. Okay. Similarly, two resistance are in parallel. Okay. If R1 and R2 are in parallel, you can find R1 R2 by R1 plus R2. Okay. You have to remember this equal resistance that are connected in series or in parallel. Okay. So now they ask to find the total resistance as well as equal resistance as well as current through each resistance. Before going to find the current through each resistance, we have to find the what is the equivalent resistance. Okay. Suppose I want to find the equivalent resistance, we have to see the source side. From the source, start from the opposite side of the source. Okay. So we have the 20 volt source. From the 20 volt source, see from the opposite side. From the opposite side, start calculating the resistance whether it is series or in parallel. Okay. Start from the opposites of source. From the opposite of source, we have the 8 ohm resistance as well as 4 ohm resistance. We have to check whether these are in series or parallel. So we have to check whether this is in series. You can see these are in series, but suppose in series circuit the current is same. Current flowing through each resistance series. Suppose that if you allow the current here, the same current flow here. Okay, from that you can easily identify both are in series. Okay, so 4 and 8 are in series. So we can find R1 plus R2 we will get total. So if you redraw the circuit, we can redraw like this. So this is 6 ohm, 6 ohm, again 3 ohm, 2 ohm, this is 20 volt. Okay. So this two are in series, we will redraw the circuit. Okay, this will become 12. Okay, this is the first step we have solved both are in series. Next you can see this 12 will be parallel with this branch. Okay, so we have to make this resistance into single resistance. Then we can make the parallel with the 12. Okay, so first we have to solve this 6 and 6 are in parallel. So if you have the current here, this will be current will be divided into the 6 ohm 6 ohm. So these two are in parallel. If you parallel with the 6 means what will happen? So since both are equal resistance means if we take parallel means it will be getting the half of the value. So if you want to solve 6 into 6 by 6 plus 6 you will be getting 3 only. So you can easily, if the resistance is same means if you take parallel means you will be getting half of the value. Okay. So 6 parallel with 6 you will be getting 3. Okay. So you can redraw the circuit now. This is 2 ohm, 3 ohm. So this 3, 6, 6 if we take parallel we will be getting again 3. Okay. And again, so again 12 ohm. Okay. So this 3 and 3 are in series. Okay. So we can make this 3 and 3 are series. We can make it to a 6 ohm. Now we have 12 ohm, 6 ohm. These two are in parallel. We take parallel 12 into 6 by 12 plus 6. Just to calculate this, what is the equivalent resistance we will be getting? Okay. So if we calculate 12 into 6 divided by 12 plus 6. Okay, 18. Okay, we will be getting 4 ohm. Okay, we will be getting 4 ohm. So this 6 and 12 are in parallel, we will be getting this 4 ohm. So this is 20 volt. So this is 22 ohm. Here, this is 4 ohm. Now you can easily find 2 and 4 are in series. So we will be getting total resistance. Our equivalent resistance is 6 ohm. So we got this 6 ohm. Okay. So now we got the equivalent resistance. So we got the equivalent resistance. Okay. But we have to find current through each resistance. That we have to find current through each resistance. Suppose question may ask current flowing through current obtained from the source. We can easily find from this. But they ask current flowing through each resistance. Okay. So what is the current flowing 2 ohm, 3 ohm, 6 ohm, as well as 4 ohm, as well as 8 ohm. Okay. That's we are going to find. So for this we have to find what is the total current of the circuit. There is a current flow from the source. For this we need the total resistance, that is the input resistance. Then we can find 6 ohm. From this find what is the total current or current supplied by the source. Okay, current supplied by the source is equal to supply voltage divided by equivalent resistance. Supply voltage is 20. Okay, and equivalent resistance is 6 ohm. So you can find, so almost we getting 3.33. So this is the current supplied by the source. Okay, so we got the current supplied by the source. So this is 3.33 amps. Okay, now we can start from the what is the current flowing through 2. So you can see here from the source 3.33 coming, the same current flowing through the 2. Okay, so they ask current flowing through each resistance means. So what is the current flowing through 2? Current flowing through 2 is nothing but again 3.3. So current flowing through 2 ohm is 3.3. Okay, you got the answer for the 2 ohm resistance. Now next you are going to find current flowing through this resistance. For this we need to, since the current is divided into 2 branches here. Okay, so we have to make into 2 resistance branch. Such that we can find use the current divider. So before going to solve this, you have to know what is the current divider rule. Okay, so if you know the current divider rule, we can solve the. Okay, so we have the 2 resistors are in parallel, which input current is I. Then current flowing through R1 is nothing but I equal to current going through resistance R1 is nothing but total current into resistance of opposite resistance. Suppose the current going through R1 is IR1 is, so this is IR2. Okay, IR1 if you want to find total current into IR2 is I2. Okay, divided by total resistance. Sorry, current going through the R1 is nothing but total current into the opposite resistance, not current. So opposite resistance R2 divided by total resistance. Suppose I want to find current flowing through R2. That is IR2 means we want to find current flowing through R2 means total current into this resistance R1 divided by R1 plus R. Okay, so you have to remember this. Suppose if you find R1, current flowing through R1 means just subtract from I, we can find the R2. Okay, so remember this formula, and using this you are going to find the current flowing through each resistance. Now, so we got current flowing through 2 ohm. So the 2 ohm, the current flowing here is 0.33. So what is the equal resistance of this branch? Equal resistance of this branch is nothing but 6 ohm, and this branch is 12 ohm. Okay. Now we are having 2 resistors are in parallel. So here we have 0.33. Okay. So this 0.33 is divided into 2 branches of 6 ohm and 12 ohm. So from this you can find what is the current flowing through this branch or this branch. Okay. Suppose I want to find current flowing through this branch means what is the current flowing through 6 ohm branch means what is the total current 0.33 into opposite resistance 12 divided by 6 plus 2. Okay, so 0.33 into 12. Okay, 0.33 into 12 divided by 80. Okay, so we got 0.2. So we got 0.22 amps. Okay, so this is 0.22 amps. Okay, so remaining current flowing through this branch. Okay, so what is the remaining current? So 0.33. Okay, so again it will be getting 0.11 here. Okay, flowing here means remaining current is 0.11 flowing here. Okay. So suppose I want to find what is the current flowing through 4 ohm and 8 ohm. You can easily find. So this branch is 12 ohm branch is addition of 4 and 8. Okay. So same current is flowing here. Both are in series. So from this you can find current flowing through 4 ohm equal to 8 ohm equal to 0.11 amps. Current flowing through 0.4 is also say 4 ohm, 8 ohm both are in series. That is nothing but 12 ohm. So from this you can find current flowing through the 4 ohm, 8 ohm is 0.1 amps. So we got current flowing through each resistance. Now we have to find what is the current flowing through 3 ohm. So they asked current flowing through each resistance. So we can find what is the current flowing through 3 ohm. 3 ohm is nothing but this branch. Okay. So current entering here is 0.2. So the current here entering is 0.2. So 0.2 is the current flowing through nothing but 3 ohm. So current flowing through 3 ohm is 0.2 amps. Okay. So this 0.22 amps is entering here and it will be leaving 0.22 amps. Okay. Again this 0.22 amps will be divided here into each resistance 6 ohm and 6 ohm. So suppose I want to find current flowing through 6 ohm, 6 ohm. How can I divide? Again you can find current divided. But since both the resistance are in same, both the resistance are in same means the same branch of resistance if it is parallel means the current will be equally divided. So you no need to find apply the current divider. Suppose both the resistance are in different resistance means we can apply the current divider. Okay. So here the current will be divided equally. With both are in equal means. So the current flowing through 6 ohm is nothing but 0.11 and this will be 0.11 amps. Okay. So current flowing through 6 ohm is both the 6 ohm resistance is 0.1. So if we easily can check this 0.1 again will come here as a 0.22. So reading here is 0.2 amps. Okay. So here the current level here is 0.11 amps. Okay. So here 0.1 will come, here 0.2 will come. Both will be added. Again it flows here as. So what is the current? 0.33. So here the total current is 0.33. So this 0.33 is divided into 0.2 to 0.11. Here 0.22 is again divided into 0.1, 0.1, and again current will be 0.22, and this current will be 0.11, and the total current here is 0.3. So these are the current flowing through each resistance. I think this is clear for you. So first of all find the total resistance, then find the current through each resistance. Here we have to mainly we have to know what is the total resistance formula as well as current divided. Current divided nothing but suppose I want to find the two resistance are parallel means you can apply the current divided. Okay. Suppose I want the current flowing through one resistance means we have to know what is the total current, then resistance of the opposite resistance divided by total resistance. So okay. Suppose the resistance are series means you can't apply current divider, then you will be applying the voltage divider. Suppose I want to find the voltage across each resistance. Okay. So here we will apply the current divider. So we move on to the second problem. Same type. Okay. Series parallel. So how to find the total resistance? First of all, you can find the total resistance, and then from this question, okay, they ask you some other question from this also you can find. Okay, so you can see here to find the equal resistance across AB. So they didn't given any source. Just they mentioned the voltage of resistance across AB. That's all they mentioned. Okay, so here the AB is mentioned means we have to see from the opposite sides. We have to see from the opposite side. You can see from this we can opposite side is this 8 ohm. Okay, so see whether these are in series or not. Okay, so you can see here 6 ohm, 8 ohm and 10 ohm are in series. Okay, so 6 ohm, 8 ohm plus 10 ohm. All three are in series. You can't confuse only two resistance. There will be three resistance. Same current going through all the three resistance. So 6 ohm, 8 ohm, 10 ohm, all three are in series. So just add it. Okay. You'll be getting as a 24 ohm. Okay, since we are in series. So redraw the circuit now. draw into single resistance of 24. If we draw into single resistance 24 ohms. Now 24, you can see from the again opposite side. Okay, this 24 parallel with the 5. So the current is dividing. Okay, so 24 parallel with the. Okay, just to calculate this, I can find. Okay, so we are getting. So we are getting 4.13. Okay, so we draw the circuit. So now we can see from the opposite side, we got 4.13, 4 ohm, 12 ohm. So these three are in again series. Okay, so again we draw the circuit. 2 ohm. So we are getting 4 ohm plus 4.13 plus 12. Okay, so we are getting how much of 8? 20.1. So these three are in series, will be getting 20.13. Okay. So now again, class AB. So this 20.13 will be parallel with the 3 ohm resistance. Just do the parallel across 3 into 20.13 divided by 3 plus 20.1. Okay. So just do 20.13 into 3 divided by 23.1. So we are getting 2.61 ohm. Okay, these two are in parallel. So again, just redraw the circuit. This is 14. 2.61. Okay. So across AB, we find. So 2 ohm plus 2.61 plus 14. So these three are in series. Will be getting us a almost 18.61. So this is the total resistance. That is the equivalent resistance what they asked. But they may ask some more questions from this problem. They may ask the current through each resistance. So instead of AB, okay, they may ask current through each resistance. So like a previous problem, just connect a voltage source here, and then we connect it will be 25 volt source. Okay, 25 volt source. From the equivalent resistance, the question may ask like this: find the current supplied by the battery. Find the current supplied by the battery. So the battery volt source is 25 volt source. Okay, so the battery voltage is 25 volt. They ask current supplied by the battery means we got the total resistance. We got the total resistance as 18.61. Okay, so equivalent resistance is 18.61. The total voltage is 25. So just divide the I equal to V by R. So we are getting as a 25 by 18.61. Okay, so we are getting 1.343. 1.343 amps is the current supplied by the battery. Okay, so we can put it here 1.343. Now again they ask current flowing through each resistance. Current flowing through each resistance, how can you find? So again we can use the current divider rule like a previous problem. So the current flowing through 2 ohm is same. Current flowing through 2 ohm, the current entering is 1.343. Again this is a 1.343. Okay, but here, so here we have to make it to a 2 branch. So that you can find the current is divided. Okay, so here the 3 ohm is there. Okay, we have to make this total resistance. What is the total resistance? Already we have calculated the total resistance. step by step. Okay. So what is this equivalent resistance? Such that we can use the current divider rule. Okay. So final step you can see here. So 2 ohm, 14. You can see here. So previous steps you can see here. This is 3 ohm, and this total resistance nothing but 20.13. 20.13. Okay. So here actually the current is entering is 1.34. Understood? So here this is a 3 ohm. This total resistance nothing but 20.13. So now we can find what is the current through 3 ohm by current divider. Okay. So you can't apply the whole circuit. If you want to current flowing through, you want to find current flowing through each resistance means you can't do it directly. We have to do this step by step. So from here you can find what is the current flowing through 3 ohm. So what is the current flowing through 3 ohm? Current flowing through 3 ohm is nothing but here total current is nothing but 1.343. So 1.343 into, if we want to find the current through 3 ohm means just to see the opposite resistance 20.13. So 20.13 divided by total resistance. Total resistance nothing but 3 plus 20.13. So 3 plus 20.13. So this is the current flowing through 3 ohm resistance. Okay. So you can calculate this 1.343 into 20.13. Okay. Divided by 23.13. Okay. So it will be 1.16 amps. 1.16 amps. So we got the current through 3 ohm is 1.16 amps. 1.16 amps we got. Okay. So now the current flowing through 3 ohm is 1.76. The remaining current what is that? Just subtract from what is the total current? 1.343. So just subtract 1.16. You will get 0.183. 0.183 is entering into 20.13. This 20.13 is nothing but this total resistance. Okay. So there in circuit there is no 20.13, but the equal resistance of the whole resistance is 20.13. So the current flowing through 0.183 nothing but this is a current. This is 0.183 is 20.13 is nothing but this side. Okay. So the 0.183 entering into 4 ohm now. The current flowing through 4 ohm is 0.18. So again giving us a 0.183 amps. Okay. Now this 0.183 again divided into, we have to make into 2 branches. Okay. Make it into 2 branches. Okay. So here 0.183 again making 2 branches means this is 5 ohm and these 3 are in single branch. This 3 are in single branch means 6, 8, 10. Okay. 6, 8, 10, 3 are in series. Okay, nothing but just add this. So we can make this equivalent resistance like this. Already we have done this. 24 ohm we will be getting. So we can redraw the circuit here. So this is 0.183. Okay, so this is 5 ohm, this is 4 ohm. Okay, and this 3 are in parallel means series means you will be getting 24. Okay, so now this 0.183 is divided into 2 branches. Already we need the current through 5 ohm. Okay, so current flowing through 5 ohm nothing but total current here is 0.183. So for this 2 resistance, what is the total current? That is a 0.183 into, if you want to find this resistance means opposite resistance 24 divided by total resistance. Okay, so we are getting 0.183 into 24 divided by 29. We will be getting 0.151. 0.151 is the current flowing through 5 ohm. Okay, just subtract 0.183. We will be getting 0.032. Approximately 0.032 amps will be flowing through 24. But actually, we don't have any 0.24 resistance. But here these 3 are in series. These 3 are in series. That will be having the 24 resistance. So current flow, if they ask current flowing through each resistance means This 0.032 is flowing through 6 ohm, 8 ohm as well as 10 ohm. Okay, so the current flowing through 6 ohm as well as current flowing through 8 ohm equal to current flowing through 10 ohm, nothing but 0.03. Why means all three are in series. All three are in series. So this will be 0.03. So now again we have two more resistors. That is a 12 ohm. 12 ohm is there as well as 14 ohm. So 14 ohm only we can tell easy. This 14 ohm nothing but the current entering here, current entering from leaving here is 1.343 months. Again it will be from ending point also again same current. So current flowing through 14 ohm also 1.343 ohm. It won't differ. Okay. And one more resistance we have to find. So suppose this is a 0.183 is coming here. Okay. So what is the current flowing through 5 ohm? Only the find 0.151. So this current is 0.151. Again the 0.151 will be added with the 0.180. Will be getting the same current. What is the 0.180? Sorry, 0.180. 0.032 is flowing here. 0.032 will be added with the 0.1. This is a 0.183 is dividing into 2 current. The 5 ohm resistance current is 0.151. Okay. If we add 0.151 with the 0.032, we will be getting 0.180. So the current flowing through both 4 ohm as well as 12 ohm will be equal. Okay. Again the 2 ohm as well as 14 ohm will be equal. Okay. So we got all the current flowing through each resistance. So what is the conclusion is that if we want to find the total resistance, we have to know what is the series, what is the total resistance for the series circuit, what is the total resistance for the parallel circuit. That you have to know. And then suppose I want to find the current through each resistance, means we have to draw the circuit separately such that we can easily divide the current by using the current divider rule. Make it to a 2 resistance such that you can apply the current divider. Okay. And also, suppose I want to, only they ask current supply to the battery, means just to find the total resistance, then find the current. What is the current? I equal to Ohm's law equal to V by R. R is the total resistance. Okay, V is the supply voltage. The same, this circuit can be applied by some other method also. So here I am doing by using the equivalent resistance. From that we are finding the current. Or we can apply some mesh analysis also we can do. Or you can analyze by the nodal also you can do. But if they ask particularly find the total resistance or find the equivalent resistance and find the current through each resistance, they ask means easily you can do by this method. Okay, find the total resistance. From that find the what is the current through each resistance. Okay, so I think clear what is how to find the equivalent resistance, as well as how to find the current through each resistance, as well as current supply by the battery. As they may ask the current through the particular resistance also they ask. Okay, suppose I want the current going through load resistance, like that they will ask. Current supply by the source they may ask. Okay, current supply by the battery may ask. Okay, keep remember do the same problem by using the mesh or nodal. Okay, and try to find current through by method of mesh. You can find what is the current through each resistance and solve whether you are getting the same answer. You can check it. Okay, and also you can do the previous problem. Previous problems also will have the to-do problem. There we can use the mesh analysis and we check whether the current flowing through each resistance we can solve. Okay. They may ask since these are the basic for the both EEE department as well as all the department will have the basic electrical and electronics engineers. Okay. From this we can easily solve from the in order to perform the circuit. Okay. Anything if you want to do better in the equivalent resistance, you can from other classes you can solve by other methods and you can solve it. Okay. Any other doubt you can ask, and they may ask some more thing. They here suppose I find the current. From that we can find the power also. They may ask the power. We can ask the voltage also. They may ask. Okay. There we can use the power formula, power equal to I square R or VA or find the power. Okay. Mainly they ask the total resistance current. They ask the